Good morning. My name is Jeffrey Palermo, and I'm the Chief Architect of ClearMeasure, also a multi-time recipient of the Microsoft MVP Award. And today I'm super excited to start a new webinar series. If you've been following us for a while, you know that we do weekly webinars, and it's essentially teaching on a different topic so that your software team can really be a world-class team competing with the best of the best. My belief for you is that every team, your team, can be absolutely world-class and first-class if equipped properly and using the right process and the right tools and the right methods. So today kicks off our 7-week seminar, our 7-week webinar on .NET DevOps for architects. And just judging from the tremendous interest in this particular one, we have so many, it looks like tons of team architects, lead engineers, development managers. We see some CTOs, a VP of engineering. We have lots and lots of software leaders on this call, and I'm really excited. Thank you so much for your time. I know your time is really valuable. So this is week 1 of .NET DevOps for architects, and we're going to dive into what DevOps is. And our whole world is the Microsoft ecosystem. And so when we talk concretely about the patterns and the tools, that is going to be focused on the .NET ecosystem. But as architects and as software leaders, we need to think about that which is going to enable our team, and that is going to equip our team. So let's get into the agenda rather quickly. And there is, as we go through the logistics, there is a Q&A feature in the Zoom software that you can ask a question. I'm pretty good about answering questions in line. But my commitment to you, as always, will be that I won't end the webinar until all the questions are answered. And I try to get this content delivered as quickly as possible. And today's topic, week 1, is the architecture overview and also a survey of common tools that are used. And of course, week 2, next week, is going to be about version control, about how, as architects and team leaders, we need to think about how our software is organized into version control, which is the beginning of a DevOps pipeline. Okay, so today these are the topics that we're going to go through in week 1 as we get through our topic for today, kicking off the .NET DevOps for Architects series. We're going to talk about the DevOps cycle, dive in deep into that. I'm going to talk about my new model for DevOps that I'm calling Onion DevOps Architecture. And you guys are seeing it first. Way back 10 years ago, I put out a model called Onion Architecture, just Onion Architecture. And it was all about how to manage dependencies within a Visual Studio solution, because those can get out of control, and how to model application architecture. And so it's been 10 years, but I'm putting out a new model, which is a larger model that wraps that one, which is Onion DevOps Architecture. And that's just, I'm naming it. So I'll also talk about the role of the architect, which is, for most of you, your role. And then talk about the common tools that go with each of the major phases, each of the major parts of a DevOps environment. And then just remind you about next week's webinar and suggest some next steps. So to get a little bit of housekeeping out of the way, I have a free offer, and let me shrink myself so you can see the text on the page. Free offer for a electronic copy of my latest book, .NET DevOps for Azure, and it will be debuted in the bookstore at the Microsoft Ignite conference, but you can get an electronic copy directly from me just by sending me an email and letting me know that you were on this webinar. For people viewing the recording, sorry about that. Come to the next webinar, and we may be offering this again. But you can also pre-order the print book on Amazon from A-Press, and there's the URL there, but pretty easy to search. But that's my latest book, and it is very prescriptive. My goal is that you fall into the pit of success when putting together your DevOps environment for a .NET software system. Okay, and also this webinar series has a lot of great information. There's lots to learn about putting together a DevOps capability for your organization. But if you want immersive, hands-on training from me directly, then come to Austin, Texas at the end of October, and you can go to this URL, bit.ly/.NET DevOps Bootcamp, and sign up for that 3-day immersive, hands-on or send some of your developers, send some of your team members. With the number of people on this webinar, and this is the first time that the actual sign up has actually been online. We will likely be selling out very quickly, and then just putting another date on the calendar, maybe sometime in the new year. But you can go there now and just easy credit card transaction to reserve your seat. And so bit.ly/.NET DevOps Bootcamp to sign up for complete hands-on immersive DevOps training. Every student will come away with having implemented a complete DevOps environment, soup to nuts, with everything that we talk about here throughout this series, and actually everything that's in my book. So you want to check that out or talk to your teammates about that. Also, another resource you might be interested in. I know a lot of you probably subscribe, but if you don't, the Azure DevOps podcast is my weekly podcast where we get people on the line to interview who have done great things, who have achieved DevOps success and are telling their stories or are talking about a particular concept. And so go to www.azuredevops.show for past episodes and show notes. So we recently had Jared Parsons, who is the lead engineer for the C# compiler and SDK team, and sharing the success story about how that team does DevOps. A most recent show is from, and I don't think the recording is come out yet, but the Windows subsystem for Linux and how that team does DevOps, and so many others. So make sure to tune in. A lot of great topics. And so let's dive in and get a quick overview of the DevOps cycle. Now, we're going to start with code, okay? Everything is around code. And before we think about DevOps, well, we have a lot of programmers, and programmers write code. And we're always thinking, okay, what does done mean? How do I get it working? How do we as team members integrate our changes? All the questions that we normally ask, that is present when we're thinking, okay, our hands are on the keyboard. How do I estimate how long it's going to take? Because I'm always being asked, hey, what's your estimate? How long is this going to take? Can we have it by tomorrow? How do we stay aligned with the architecture? All right. But around the code is engineering practices, okay, and technical decisions that need to be made. And some of the questions that we ask there is this new major feature going to need an architecture change? We need to update our architecture blueprints. Should we bring in any new libraries? Are we missing any important technical decisions? How do I set expectations about how much effort this new feature needs when it may have many pieces to it? And so with our team, if you have a team where you have multiple developers and someone who's designated as the lead engineer or the team lead, that person may formally have a role to keep everybody aligned. But that's another cycle that spins around the code. Further, we have another layer in our DevOps model, in our DevOps cycle, that is the product cycle. And you may have product managers, you may have various customer surrogates who really, really know the market. And they're asking themselves the question, okay, this new requirement that we have, this new objective, how should we design the user interface? What's the best way to cause our user base to take the action we want them to take? Because in the 90s and 2000s, a lot of companies were just doing a basic digital transformation. And but today, it really is about getting our audience to take the action that we want them to take. If it's e-commerce, we want them to buy more stuff from us and buy more frequently. If the software is used by the shipping dock to bring in shipments to receive materials, we want them to be really efficient and accurate and be able to bring those things in. So regardless of who is using your software, you want them to behave in a certain way. And when we change the software, we're actually looking to influence what is happening and give people a better experience, to cause them to buy more from us, or to equip them with the ability to be more efficient. But either way, we're looking to influence the behavior of our audience, our customers, our users. And so whoever represents the product team is asking those questions. And should this be a desktop app, tablet app, phone app, voice? If we're just talking to Alexa with an Alexa skill and having it do something, and they're asking themselves all those kinds of questions, and those are very important. And then wrapped around that is our strategy layer. And that's where requirements come from. The old requirement notion where we're creating the conceptual definition of what the heck we're going to build or what the heck we're going to change. And it's a business objective. It's a business hypothesis. I'll talk a little bit about that later. And those questions are, what are the features that are going to help accomplish next year's, next quarter, next month's business objectives? Why isn't my audience doing what I want them to do now? Are we engaging the right type of people? Are we offering what our market wants? Now, there's developers on this call that live inside that code layer. Then yes, all these other things may seem boring, but the more you pay attention to them, the more effective you're going to be. And there's probably some on here that are they're in the executive suite. You are in strategy. You are asking those types of questions, and you just want it to get done as quickly as possible. And that's natural. So let's jump back into code, and let's go from the questions to ask, or the input into the cycle, and the validation that needs to come out of the cycle, okay? And at the code level, hands on keyboard, some of the questions, some of the validations after you've built something, after you've written some code, is, did my test pass? Does it work on my box? Does my private build pass? Did it deploy and pass all of the full system tests, or did it fail spectacularly on deploying to that first line environment? Is it done? Did it meet the definition of done that we as a team have? And finally, is it ready for a pull request? Okay. Those are all questions that are validating questions. And when you are in the code, and by the way, in a future week webinar, we are going to break down this code cycle into its different parts. Because of course, if we're writing a test and it fails and we're making it pass, there's a TDD cycle, and then there is a control F5, run it locally, and then change some code, run it locally. That's a cycle that spins. And then we run the private build, and maybe we do an interim commit. That's a cycle. And then we're integrating with our team's code. That's another cycle. And then finally, okay, is it ready for a pull request? Now I think I'm done with this particular feature that I've implemented, or part of a feature, and it's ready for a pull request so that it can be yielded back up to the next layer up. Now, engineering, team as a whole, the validation questions that are common there is, does the pull request, the changes that have been submitted, do they pass our formal inspection checklist? By the way, you should have an actual checklist by which you accept a pull request. All right, that's for another story, another week. Does the branch match our architectural blueprints? Did we use the patterns and libraries determined for this particular feature? And overall, is the pace of our team's delivery adequate, or do we need to find some solutions to speed it up? So those are some common validation questions at the engineering layer. At the product layer, we might ask, do the screens match the wireframes? Does the feel of our experience match? Is the desired user path the easiest to follow? And finally, just skipping through, because I know you all can read what's on the screen. Can I sell this as it is? Is it ready to release? Can I sell this? And then at the strategy level, where business objectives were formed and initiatives were commissioned, and we actually came up with, you know what, we're going to have to build or change something. The validation is our audience, now that they're actually using the software, now that it's actually in production, is the audience changing their behavior? Are we making more money accomplishing the business objective? Is the audience doing more of the right thing? Did we get more engagement with the right audience? Did we get more of an audience, a user base, a customer base? Are our business metrics improving? Okay, that's the bottom line right there. Our business metrics, because if we didn't want to change anything about how our business is succeeding, why would we invest in this software? Okay, so this model is what I'm calling onion DevOps architecture. And your role as an architect is to work at the boundaries, okay? The boundary between defining what the heck we're gonna do and how are we gonna influence our users, that's product, and then how are we gonna build it, key technical decisions, and then the actual coding process and builds and deployments, and the technical patterns and the libraries, and there are boundaries between each one. And so if for any new architects or maybe aspiring architects on this webinar, architects don't work inside of a particular layer. Architects help translate from the executive level at a business to actually getting the code that is necessary to make that executive initiative reality, and shepherding this whole this whole system, this whole process. Okay, now let's talk about principles a little bit, because right now I have 3 layers surrounding the really techie bits that we do with the code. But there are principles with each layer, and you know what? There can be any number of layers, but this is the mental model that you should have as an architect. And if you're putting together a DevOps environment so that your software team, so that your developers can really succeed, and all the structure is around them so that they can shine, and so that you can crank out the business software that your organization depends on. So each of the layers is a cycle. And if you've ever done TDD, you're familiar with arrange, act, assert, that's a cycle, or define, do, and then get data, analyze, act, assess. It's you come up with something to do, you define something, you design something, then you do it, and then you check it. Were my design assumptions correct? Okay, so each layer has a cycle, and each layer, imagine this, another analogy, as a solar system. The interior cycles must spin faster than the exterior cycles. Okay, if the code and engineering and product cycles are spinning at the same speed as strategy, well, that was some big problems in the late 90s in the waterfall software method that really gave rise to the agile software movement that really kicked off in 2001. And we've seen from 2001 to about 2010, 11, that in the definition of interior cycles with releases and then sprints from the Scrum methodology gaining popularity. And so the concept of a cycle isn't new, but the definition of how many cycles should there be and what do we do within each cycle. So the interior cycles must spin faster than the exterior. Here's a sampling of cycles, but if you have a few more, that's perfectly fine. Each layer must define success and what it means to be done and that worked. Okay, it must do some level of design so that it can pass off that design to the next interior layer. And then once the product gets back to it, it needs to have some type of verification or validation that it was done and that it actually works, because everything is a hypothesis. we can say it doesn't work. If you build it, they will come. That doesn't work. There's lots of people who've created a new piece of software and it didn't actually meet the business objective that was desired. And studies of the Scrum methodology with the product owner defining priorities in a backlog yield about a 33% success rate. And so people with better data can have better insights, but everything that we decide to build or change in the software, we need to treat it as a hypothesis and frame it as such, and define an experiment or a test that is actually going to give us the information of, hey, was our hypothesis correct? Did it actually entice the user to do what we wanted them to do or improve the business metric that we wanted it to improve? Or did it not really do that? And then we need to adjust and keep working. All right. Now, let's go from this model to just a concrete process flow that I think everyone will understand. And this is a common process flow. And you can also think of this as a series of columns on a Kanban board, or just whatever board. If you have a board on a whiteboard and you move cards from the side, Scrum popularized the concept of a board where the work was on the board. And Jira uses this, and Azure Boards uses this. And so many project management tools take a unit of work, a card, sticky note, and move it from left to right. So each one of these things that you see here, there's 12 of them. Just imagine columns from left to right, okay? And so the top row is all about design decisions before even hands get on the keyboard and we start working with code. And then the bottom layer, the bottom, are all about validating the code that was built, determining to move it forward, and actually shepherding it and operating it in the hands of our audience or user or customer base. Okay. Now, the first one, and they go in sequence, Kanban has shown us, and the Toyota lean manufacturing methods have taught us that the more we can drive to single piece flow, the higher overall throughput we are going to get. Okay. So conceptual definition is the first, and it's what the heck is this? What's the business objective? What are we trying to accomplish? And overall, what do we think that we should do in order to accomplish that? That's a lot of strategy. And it could start at the most high level of, I think that we should build a new application. I think we should build a new mobile app. I think that we should have a voice activated skill for Alexa. I think that our doctors walking around the hospital shouldn't have to use an audio recorder to do medical dictations. I think that they should be able to tap a button on their smartphone and just do it because they have that device and just upload it. It's a guess, it's a hypothesis, but it's what the heck are we going to build? What the heck are we going to do? Then the next bit of design, and it's common in product management, is, okay, this is the concept. And by the way, the conceptual definition is the old school requirements. Now, requirements ended up being a terrible form with the system shall and the system will, whereas the system is not the goal. Humans, people, we want people's lives to be better. We want people to buy more from us. We want people to be more efficient. We want people to be more accurate in their job. And so we're going to have the system be their helper so that they can achieve more fulfillment. So the whole requirements with the system shall, we want the people to do. We want the system to assist the person so that the person is better, faster, a more loyal customer. And so user experience design is all about is desktop feature. How is the user going to use that software? Wireframes are common. Then technical design, what libraries are we going to use? What technical patterns do we need to put in place? Do I need a new architectural element in my 4+1 architecture blueprints? And then now we get into what I would call the development cycle with acceptance test criteria, test design, whereas this is the definition of done. For people using Scrum, that Scrum definition of done. And before we actually type out the code, this is the team's shared understanding of what the heck we're doing here, and just, hey, how are we going to test this thing? If I was to have it done right now, what sequence of buttons would you click, and what would you do that someone else on the team would say, oh yeah, it's done. That's right. Acceptance criteria, test. Then the developers, we write code. We work with our version control system with builds. We produce release candidates, and we'll go into that next week for how to set up version control for this process. But then we come right back out to the layers where we match validation. So the first line TDD environment, the test-driven development environment, that's the first time we deployed our software. And that's the first time it all comes together so that we can look at it from the same perspective as technical design. Does it match? Does the architecture match? Do the performance characteristics match? Is it throwing errors, or is it doing what we want? Are the right libraries that we chose working out for us? Then the second line manual test environment is matched up with user experience, so that you can see that cycle coming back where we have people from the product team or customer surrogates looking at it and saying, yeah, does it have the right feel? Is it what I imagined? Does it match these wireframes? Or now that I see these wireframes actually put into practice, do I want to make some adjustments? So that validation is paired with user experience. Then the production environment is when people are actually using it. Our audience is actually using it and being influenced by the hypothesis that we specified when we were defining the concept. And that is where we can take firsthand feedback from them if we know who they are, or we can measure if they're buying more from us, if it's the e-commerce scenario, and we can test our hypothesis that we defined way back in conceptual definition. So you see there is a mirror effect all around the technical parts of the DevOps pipeline, where we make some technical decisions and then we validate them. And security, performance, compatibility, interoperability, there's so many technical decisions that need to be made. And then there is how the user's experience is going to be, how we're going to influence and enable the user. And that's validated in an environment that is deployed. And then production is our users, they're really using it. And then we validate it against the concept that we hypothesized. And then on an ongoing basis, we operate and support the system, and we're constantly harvesting data to provide an inventory of data to analyze for the next concept, the next strategic hypothesis. All right, so that's how it maps, and that's so important to put our DevOps cycle together. So let's jump into common tools now, because there's common tools across this whole ecosystem. And they're not complicated, but it's good just to know, if you haven't been looking at some of them, what to look at, because you need a method, you need some skills, and you need some tools in every one of those places. So for the strategy level, concept definition, requirements, good old bullet lists are really good. Word doc templates, Azure Boards is really great at tracking those. If you're using the default setup, that is going to be the Epic board that you'll use for that. GitHub issues, and you can tag them as ideas, hypotheses. But every one of these, remember, every one of these, frame it as a hypothesis or an assumption, and it must be validated. We're all making assumptions. We're making educated guesses based on all the information that we have available to us. Okay. So at the product level, the user experience level, the human interfacing, common tools are balsamic wireframes or PowerPoint wireframes, whiteboard with the sequencing of what's going to happen, storyboarding, a pencil on paper, and then take a picture of it with a camera or a smartphone, and then put it into a work tracking system or even OneDrive. And so the storyboard, the illustration of how a person is going to use this software, you can make it like a comic strip to illustrate how we want our audience to use our software and behave. And I have been using the term audience specifically. The term user is used, oh, they're a software user, they're a software user. Okay, they are a software user, but software users are so diverse that they don't think of themselves as software users. They think of themselves as they're working the shipping dock, or they're a probation officer, or they're a judge's clerk, or they are they're a salesman. I mean, they use so many systems that they don't think of themselves as a user of your systems. They think of themselves as what they're doing, what their profession is, and then they want your system to assist them. They don't want to be a user to your system. They want your system to be a helper to them. And so that's a good mindset that I like to have. Then tools for engineering, IT, all the technical decisions. Visio still continues to be great. Diagrams. If you can't draw it, you can't build it. And if it can't be drawn, it can't be built. Okay. Even if you're using a pen and a napkin, just some type of design drawing, and there's so many other drawing tools available. Just do a Google search, but my favorite continues to be Visio. I know in the chat there's some comments about some other good ones. Roslyn rule sets enable some of the design patterns and coding styles and rules to be enforced in an automated way. Also resharper.settings that allows some ongoing static analysis. 4+1 architectural blueprints. That method helps define the different layers, the runtime layer of the software, the process layer, the logical dependency layer, and then the development layer and all the dependencies of what it takes to, what you have to have set up on your local workstation in order to even work with a piece of software. That's the development layer. That style of architectural blueprint is a great tool. And then sequence diagrams. Sequence diagrams are your friend. I love using websequencediagrams.com, I think, or .net. Or you just do on a whiteboard, because so many things to illustrate. You can say, you know what, let's use CQRS as a design pattern. And we're going to define commands for this user action and this user action. It's okay to say that. And if everybody has the absolute shared understanding of exactly how to implement that by the pattern name, then you're great, because your team's been doing it for so long. But if everybody doesn't know exactly what you mean, guess what? You need to provide a picture. So a sequence diagram provides a tool for the architect and architect, lead engineer, that same type of role, the supervisor or guide of the engineering team, to provide a picture that illustrates exactly the sequence of things that will happen in the software behind a user action. What happens first, then what happens next. And a lot of times, if you draw a sequence diagram, the vertical lines will be a class, and allows you to even specify names of classes if you need to. And then the lines between a vertical line tend to be methods. So you can get really concrete, and it helps to illustrate the choice of a pattern and how to implement it. All right, so tools for code. Now, there are so many tools out there, but Visual Studio 2019, ReSharper is a great tool add-in. In-unit or X-unit, you need to be using one of them. Azure Pipelines provides the building blocks for a cloud-hosted build server. Jenkins and TeamCity are out there, but everything's going cloud-based. And so the fact that Azure Pipelines just completely runs for you, and all you have to do is configure it, and then you essentially have the build infrastructure there, and you don't have to set up yet additional virtual machines in some other place, is amazing. And then Selenium it continues to be a dominant tool for web-based full system testing on top of in-unit or X-unit. And then for for VM and complex deployment scenarios, Octopus Deploy provides fantastic support for complex deployment scenarios like a tenant per customer, so that if you have multiple production environments and multiple manual test environments and you want to have rules around that, Octopus Deploy provides a ton of sophistication around complex deployment scenarios, and it integrates nicely with any build server. And of course, you'll be using C# and whatnot. But those are DevOps tools. And then for engineering team validation, you'll want to use pull requests, and you'll want to use an inspection checklist paired with your pull request. That is an absolute must for the validation level at the team level before you kind of push it over to your business stakeholders that represent the product layer. You really want to go through your checklist every time, because probably every one of you on this call has had a point where you push something over to your business counterparts and say, hey, check it out, and they pull it up and it just blows up on the first screen, or there's something kind of obvious wrong with it. Whereas a checklist, we're all going fast, but a checklist can really help make sure that nothing simple is missed, and it increases quality. All right, for the product validation layer, again, all of these are paired with the design decisions and the specification at the start of that cycle, okay? Bug and issue reports, Azure test plans are great. Azure Test Plans is paired with a Chrome extension for recorded test sessions where your people who are doing manual testing can just click a button and their entire screen is recorded and just stored automatically in Azure Test Plans, so that when a problem occurs, they don't have to try to remember what they were doing, because a lot of times they'll forget and then you don't get all the information. All right, and then at the strategic level or the production release, releasing to our audience, feature flags are great because, for example, if we just want to release it to our day shift at the shipping dock, then we can use feature flags for that. App Insights, feedback reporting, Stackify, to a telemetry data warehouse where we don't just have logs in our telemetry, but we have events and we have metrics, and we can actually use Power BI and Excel and Tableau because we have all the data that a data warehouse needs, okay? So this is our process. I want to give a quick illustration, just a verbal illustration of a scenario that would go through this, okay? And so here's an objective. It's a hypothesis. Let's say we have shipping software that takes in shipments. At our shipping dock, we have a barcode scanner, and we scan barcodes and then scan it, and it reads it in through a USB cable. And then our people use a mouse and click on the receive button. And so the hypothesis is if we were to automatically scan it and mark that package as received, then maybe shipping intake velocity would increase, because we're kind of getting backlogged and we're just not going fast enough. And so that's the conceptual definition. Now let's move to user experience. So the user experience will say, you know what, instead of having to click on the receive button, how about when I scan it, let's just automatically mark it as received and act as if they had moved the mouse over to that button and clicked it. And if the barcode's not found in the system, then an original error happens. Well, the technical design would say, you know what, let's use the command pattern for the receive command and define that, rather than have code that then uses an event handler behind a button click. And so then in coding, we would define acceptance tests, full system tests that would make sure that happens. And then on the validation side, we would have a formal inspection in our pull request and make sure that it complied with team standards. And then the product management team, once they're validating, they would actually test it and make sure that it works, and that, you know what, I think this is going to be faster. And then we deploy it with a feature flag to only the day shift, so that the supervisors can be present and can monitor to make sure that we didn't accidentally slow down productivity through a mistake of some sort. and see how things are going and get feedback from the people who are bringing in the shipments. And then we can use shift reports and validate with throughput metrics that our hypothesis was actually correct, that doing that change to the software actually worked. Now that's a very specific change to an existing system. There's other higher order hypotheses, such as, you know what, the different color or the different location of a button would cause more customer purchases. Or maybe, you know, providing some new feature as a mobile app is going to increase revenue. That's a hypothesis. Or adding, you know, a new feature to an existing system is going to increase customer retention. Or building a brand new system that does XYZ will help us gain new customers. Those are all hypotheses, okay? And so we want to make sure that we're framing it as such and not assuming that an assumption is a fact, all right? Okay, now remember, architects work at the boundaries. And so when you are putting together your team's DevOps environment, make sure that you account for all of the boundaries between the layers and that every layer can complete a cycle. All right, here's an anti-pattern. Many of you have probably been in a scenario where there is a QA team or a tester that comes in after the fact and tests the code. And in some cases, the tester has to ramp up on the requirements in order to test. And the testing happens after the code. And you all remember how frustrated you felt at that situation, because the tester would file bugs, would raise up problems that were really comments on the design, not comments on how the design was implemented. Now, the problem there is that we did not have a cycle present. We had a validation of an absent design. They were validating and they were creating and making assumptions about design, and they had to, because their entire workflow happened after it was already built. So all they could do was object to the designer, say, you know what? I know that screen is built that way, and I know that it was built according to the wireframe, but that's not actually going to accomplish the goal, because they were just at the back end. So make sure that everything that needs to happen, everything that needs to be checked is balanced, and it has a complete cycle. And at the beginning of the cycle is design, which are decisions, which are assumptions. At the beginning of the cycle is design, and then there's inner cycle of implementation. And at the end of the cycle is validation of the design, validation of the assumption. So if you have a dedicated testing crew and organizationally, they just haven't been completely fully integrated, as you know, Scrum calls for a cross-functional team. DevOps goes a step further and says not just the development, engineering, testing, product management, but also operations should be part of that cross-functional team. If organizationally you still have some silos, process-wise, you can start to break down those silos by getting them, define a layer for them where they are doing design ahead of implementation, and then have corresponding validation after implementation, and that completes the cycle. And so your coding is wrapped by a technical cycle, by a product user experience cycle, and then by a requirements and a strategy cycle. And in your organization, you might need a few more cycles, but that's the model. That's how to think about constructing your DevOps environment. Now, you take the beginnings of all the cycles and the ends of all the cycles, and you straighten it out to a pipeline, an assembly line, a factory floor, a series of columns on your Kanban board. And that is your DevOps pipeline, okay? Now, sometimes we say deployment pipeline for just the environments, for just the progression from environment to environment. But when we think about the complete DevOps environment, that entire chain is your pipeline. The pipeline starts with a strategic assumption. That's a hypothesis. That is a new requirement that we think is a good thing to do. That's what starts the pipeline. And then it goes down to how are we going to influence our users, user experience design? How are we going to make it happen? What are the key technology decisions? Now, how should it be implemented? Acceptance criteria, definition of done, do the coding, builds, package, version, now deploy to the first line TDD environment to check the techie stuff, then to the manual environment to check the user experience, then to the production environment, groups of users at a time to start validating that strategic hypothesis. That is the whole pipeline. And so as an architect, your work is at the boundaries, making sure that there are boundaries, making sure on those columns on your Kanban board, making sure that they exist, that someone owns it or a role owns it, and it's progressing to the right, and that each handoff is small in nature and is well defined. Okay, as an architect, your work is at the boundaries. So we love enabling our customers, and I love teaching and coaching, and every one of you can be an absolutely world-class software engineering team when you implement the right tools, methods, and get your team the right skills. And we've done that for a number of companies. You can see those testimonials and stories on our website, from jump starts to DevOps implementations to help speed things up, to implementing DevOps for legacy systems that might resist it, because that happens a lot. But we want you to be self-sufficient. And so, some next steps are, if any of this, if you are looking at your organization and thinking, you know what, we need to fill in some of our gaps, just give me a call. Go to our website, reach out, and we'll have a conversation, and we'll figure out how to fill those gaps. But the next step for you is to assess your organization and harvest your onion DevOps architecture from what your organization is doing now. Draw the layers that your organization has implemented and make sure that you have at least the 3 layers wrapping around the coding that we talked about today. And you might have more, that's fine. But assess for yourself what layers you've implemented, and assess if every one of your layers is a complete cycle, or if you're missing a design element, or if you're missing a validation element. Okay. Now, next week topic, we're going to dive deep into the version control structure. You can make some really bad mistakes when putting together your Git repository and laying down your source code that are going to make the rest of your DevOps pipeline from there just a disaster, and you're constantly going to be compensating for it. So we talked today about the architecture, the tools, and we did the overview of the pre-code design process and how to put together those cycles. Next week, if you have any colleagues who are, maybe they're the ones who are about to create a new Visual Studio solution structure or create a new Git repository, invite them to next week's webinar. We're going to dive deep into it. There are some rules that you need to follow, and the rest of the DevOps pipeline will go well for you. Okay. All right. So let me jump into a few questions while I put up the contact information. Take down my email address, Twitter, and it looks like bit.ly/.NET DevOps Bootcamp. The site's down. Okay, so you can also get to it with .NET DevOps Bootcamp.eventbrite.com, and because it's the sign up is on Eventbrite. So .NET DevOps Bootcamp.eventbrite.com, and send me an email if you have any trouble and you need to get on the list, send me an email. I will make sure that you get signed up. Okay. And let's see. Sequencediagram.org was another recommendation. Axure is another recommendation from people on the chat. And for you who attended this webinar, you will receive ability to get a recording that you can share with your colleagues. That's your benefit from being here in person. You will get a recording you can share with your colleagues, and it'll be posted online for a time, but it's exclusive just to you. It won't be put in its entirety in public. We may use some of it for other cases, but we'll do this again maybe next quarter. I'm glad it's useful. Okay. There's a comment that this DevOps model works for all languages and platforms, and absolutely it does. Doesn't matter what language you choose. It works. It's a method. It absolutely works with all languages and platforms. So awesome. Okay. Well, thank you so much for your time. Thank you so much for your time. And remember, next week, sign up for it. We'll send out an email reminder, version control system structure. We'll dive in deep into how to set that up properly to enable your DevOps environment. And in the meantime, send me a question, send me an email, jeffrey@clear-measure.com, or a comment on Twitter. And there's my phone number. Give me a call. Be happy to talk and answer questions, because my belief is that equipped properly, your team can be world-class, competing with any other software company that you might hear about on the news that's doing great things. All right. Thank you so much, and have a great day. God bless.